Hello, everyone, and welcome. I do have the top of the hour. So, on behalf of Idexcel, we take immense pleasure and privilege in welcoming you all to our webinar, Scale Your Machine Learning with MLOps. Next slide, please. We're going to go over the agenda for this webinar. We're going to start with an introduction to Idexcel service offerings, the overview of the MLOps processes and benefits, MLOps using SageMaker, and finish with an MLOps demo. About us. Idexcel is a professional services and technology solutions provider headquartered in Herndon, Virginia, with over 20 years of experience in implementing complex technologies, a woman and minority owned organization, and our esteemed clientele includes commercial clients across industries, public sector, and nonprofits. When we move on to our expertise, we are an Amazon Web Services AWS advanced tier service partner specializing in artificial intelligence, machine learning, data services, and cloud services for both commercial and public sector customers. We have over 140 plus AWS certified cloud practitioners, 15 plus AI and ML experts, and 40 plus big data and analytics experts on our team, holding various competencies within the AWS ecosystem. We are ISO 27001 certified by British Standards, BSI for Information Security Management. Our AWS partnership, Idexcel is more focused on supporting the AWS cloud. As you are aware, we are an Amazon Web Services advanced tier service partner and reseller. We achieved AWS competencies in migration, DevOps, and financial services, are an Amazon EC2 for Windows Server and Amazon Redshift delivery partner, have obtained AWS partnership for providing robust technology solutions, have been recognized as a public sector partner with authorization to resell and service AWS GovCloud, and are also a preferred partner for the well-architected framework, a WAF partner program, and an immersion day planner. Our core service areas. Now, these are the 4 core areas we specialize in with extensive expertise in cloud services, cloud native services, automation and AI, and data platforms and intelligence. Now, let's get to know the speakers briefly before we go ahead and start our presentation. Sachin is a senior data scientist at Idexcel, based out of Bangalore, India. He holds a Master of Science degree from Liverpool John Moores University, UK, specializing in AI and ML. He has over 7 years of industry experience in AI and ML, particularly solving challenges in NLP and CV and application around it using AWS cloud technologies. Sachin, earlier to Idexcel, has worked in developing AI, ML products and solutions for various startups, mainly in the healthcare and fintech verticals. Murali. Murali is a data scientist and ML ops engineer at Idexcel, located in Virginia, US. He holds a Master of Science degree from Northeastern University in Boston, specializing in data science. He has extensive experience in developing end-to-end machine learning, project lifecycle involving various machine learning use cases with specific focus on NLP. He is skilled at building fully automated ML pipelines that enables large-scale ML model building, training, and deployment with a rich experience working with Amazon SageMaker. So I will go ahead and turn the call over to Sachin. Thank you very much for the introduction. Sachin, please go ahead.
Thank you, Ashley. Thank you all for joining us today on the webinar, Scale Your Machine Learning with MLOps. So let's get started by discussing the overview of MLOps, its process, and its benefits. Okay, so here let's understand some of the common steps involved in any machine learning project for that sake. Assuming this as a supervised problem, firstly, we will start by collecting and preparing data, ensuring that the data is in a suitable format for analysis. We then visualize this data to gain insights, perform and check for any anomalies as such. Example, missing values or outliers. If the data is unlabeled, we label it accordingly. And it is essential to check for bias in the data and ensure that the model's performance is unbiased. So to optimize further on the model performance, we store features that we don't want to convert to features every time we run the model. And then we select the appropriate algorithm for the problem based on the problem we are trying to solve, as there are many algorithms already available. The next step is to train the model using this label data, and later we fine tune the model by adjusting the parameters such as learning rate, epochs, the batch size, and etc. and so on. It is then essential to manage and monitor the model's performance by using metrics to evaluate it. So this allows us to make some adjustments and optimize the model's performance. Finally, we use CI/CD, that is continuous integration and deployment, to deploy our code and ensure that our model remains up to date with changes to the data or on the model or the problem that we are trying to solve. Okay. All right. So yeah. Next we'll try and see what exactly goes under machine learning lifecycle. So here, let me walk you through the typical machine learning lifecycle workflow. Firstly, we need to understand the business problem, and then it is very essential for us to translate it into ML problem. So once we have a clear understanding of what we want to solve, we then move to data collection, and then selection of algorithm that we want to choose, and evaluation metric that is right for that particular problem. In the data collection stage, we gather relevant data from various sources and integrate it together, followed by a data preparation. So in this step, we clean and pre-process the data to make it suitable for analysis. In the next step, that is the data visualization and the analysis, that allow us to gain insight and understand patterns, the data patterns. Followed by feature engineer, which is a very crucial step in our modeling part. So where we extract and select relevant features from the data to train our model, we then move on to model training and fine-tuning the hyperparameters, thereby optimizing our model performances. Later, to evaluate our model accuracy or a threshold or some kind of performance metrics, the KPI that we follow within our project lifecycle, this model evaluation is very much essential. Once we are satisfied with our model's performance, we move on to deployment and then monitor it regularly to ensure it follows a continuous success. Okay. So let's begin with our core technical section, that is MLOps. So what is MLOps? MLOps is a set of processes that help organize, maintain, and build machine learning system. The main aim here is to move machine learning models from design to production with agility. Having said that, and also monitor the models to meet the expected business goals. MLOps helps companies streamline their end-to-end machine learning lifecycle and boost productivity of data scientists or the MLOps teams that are involved throughout automating and standardizing MLOps steps such as building, training, deploying, monitoring, and governance of the model while maintaining the model accuracy and enhancing security and compliance. So the key component here is the operational practices, that is MLOps, that is more or less very similar to the DevOps, and is more than just a set of services or a technologies that is involved, which requires right people with the right skills, following some of the standardized processes to successfully operate or orchestrate machine learning at scale. Okay, now let's try and understand why MLOps. So as we are seeing, MLOps is gaining attention in the field of data science and machine learning We'll try and understand or learn why MLOps is important, how it can benefit organizations that rely on machine learning models. One of the primary reasons why MLOps is important is that it helps organizations to ensure that their machine learning models are accurate, reliable, and efficient. This is particularly important in applications where machine learning models are used to make some critical decisions, such as that could be in the healthcare, finance, or very common autonomous vehicles. By implementing MLOps practice, organizations can reduce the risk of model failures, improve model performance, and they can enhance faster deployments and ensuring that the models are updated and maintained regularly. Followed by which it helps organization to reduce the time and cost involved in deploying machine learning models to production. This is because MLOps provides a framework for automating many of the repetitive and time-consuming tasks that are involved in deploying and managing machine learning models, which mainly emphasizes or which other than this managing and deploying, it focuses on the business problem and the solution. Another important reason is it requires collaboration and communication between different teams that are involved in the machine learning projects. This is because MLOps provides a common framework and a set of tools that can be used by data scientists, DevOps engineers, or data engineers and IT operation teams to work together on a machine learning project or a product by breaking down the silos between different teams and enabling the teams to work efficiently. Apart from this, it also helps organizations to ensure that their machine learning models are compliant with relevant regulations and standards. This is particularly important in the industries such as healthcare and finance, where there are strict regulations required to govern the use of sensitive data and so on. Okay. Now we'll walk through, or I'll walk through on the MLOps lifecycle. So as we can see here, it is an iterative processes. Okay, the first step here is the machine learning development. In this phase, robust ML models are developed, evaluated, and tested on a specific task involving a lot of experiments. And then comes training operationalization. This phase is all about automating and building the workflow for the process of packaging, testing, and deploying repeatable and reliable training pipelines. And then comes continuous training. This phase mainly concerns repetitive execution of the training pipeline in response to a new data or on a code change or on a scheduled training job. And then a very important step, model deployment. In this phase, packaging, testing, and deploying model to a serving environment is done for both online experimentation for a comparison and also to the production service platform for the user inference. Prediction. In this phase, deployed production model is ready to serve the user inference request. And then comes one more crucial or important step, that is continuous monitoring. This phase is all about monitoring the effectiveness and efficiency of the deployed model. And then data and model management. This is a central and a cross-cutting crucial function that is mainly meant for governing machine learning artifacts to support auditability, traceability, and adherence to compliance standards. Okay. Okay. Now under the MLOps practices, right? So here we are representing a typical presentation of MLOps practices that is associated with any machine learning project. So whenever we start off with any of the machine learning project, we have a business problem to solve. And then we do little bit of research over it and see if a machine learning solution is a right fit for this business problem. And once we determine machine learning is a good fit, and then we frame the business problem into a machine learning problem, and then we kick off the machine learning project. Once the project is started, there are, the team of data scientists, machine learning engineers, DevOps engineers, and data engineers, and so on and so forth. Then they start off with three major activities. One is on preparing the data part, and then the model building and the training part, and finally, the most important one, the deployment and the monitoring part. At first, we will start off with the data part. So typically, what really happens over here is there will be different roles in the machine learning projects, like as I mentioned, data engineers. So, and data scientists and machine learning engineers, but it could also be that there is just like one man in the team in a smaller organization who is working end to end. So whichever is the scenario, assuming that there is a team of data scientists, machine learning engineers, data engineers, particularly data engineer would usually start out with collecting data from different sources and integrating it from the various sources, assuming, okay, we could assume that the number of data sources are in tens or of hundreds of different sources. I could give you an example of an IoT-based applications where there could be like hundreds of sensors which are like sending data in real time. Also, it could be a batch of data that is streamed. So all of this has to be taken care, for which you have to do a data integration. And we all know that raw data cannot be directly used for the modeling purpose. So you will have to do some sort of cleaning. And then you will have to analyze the data and prepare your data in such a way that it could be used for your model building training purposes. So once you have the data in the right format, then the data scientists or machine learning engineers starts the model building activity, followed up with the training activity. And then he or she has to do a lot of feature engineering to determine which is the most optimal set of features for the particular chosen model. And then, finally, data scientist comes with, the baseline model. And then he iteratively starts improving this baseline model by performing hyperparameter tuning, or by getting in additional data, or by, correcting the biases within his data, and so on and so forth. So then once you have achieved a good model, then you check whether your model meets the business goal. If not, then it goes again into this iterative cycle of going and collecting more data and correcting your data in order to improve your model performance. Or again, you might want to do some more feature engineering or feature augmentation in order to achieve the business goal. After a several iterative cycle of this activities, model building, training, and fine tuning, finally you will end up meeting your business goal. And now the model now the model is deployed by a DevOps engineer, but the actual story doesn't end after the deployment. The crucial part or the most missed out part in the machine learning lifecycle is the model monitoring. Until the model performs as expected in the production environment, this process or the cycle will continue. As there is a lot of automations involved, to facilitate this, we have code build pipelines or the Jenkins pipelines, and now the SageMaker pipelines, making it more automated and more streamlined to reduce all the bottlenecks that we could see impacting productivity, performance, and cost of the machine learning project. And that's why we need right MLOps architecture corresponding to the machine learning problem that we are solving. Okay. We'll take step by step. So in this, we are going to discuss about the development phase of the MLOps, followed up with the deployment phase. Since I've covered initial phase of the development activity in the MLOps pipeline, that is data gathering and preparation, here we'll start off with the process of training and fine-tuning different machine learning models and evaluating the performance of these models. Assuming that the models are performing well, data scientist or a DevOps engineer would then go ahead and deploy these models so it can be used for generating predictions, right? And then final step, and certainly a crucial one, is to monitor these models that is hosted in the production. as we know, the world is constantly changing and evolving. So the older your model gets, as the data gets older, the worse is it might affect the predictions. By monitoring the quality of your model, you will know if it's the time to retrain your model or perhaps gather new data for the problem that you have solved. Every data scientist will usually follow some process along these lines, more or less, whether it is a small team who has just started, or if there is a pipeline that has been established. Whenever they are just starting off with this process, it is likely to be entirely manual. But as business embrace and machine learning across the organization, right, process, manual workflows for building, training, deploying tend to become bottlenecks for innovations. So even a single model that is there in the production needs to be monitored, managed, and retrained to maintain the quality of its predictions, which is not possible without the right operational practices in place. So these challenges, some of these challenges can, badly or negatively can impact data scientist productivity, not just the model performance and cost, but also a business problem that we have solved altogether. Okay. So here in the MLOps deployment phase, we have three main important steps, that is continuous integration, continuous training, and continuous deployment. So it is a set of best practices that is involved in MLOps to automate the process of building, testing, and deploying machine learning models. So here, CI/CD pipeline helps to reduce the time and cost of developing and deploying machine learning models by automating the entire process from code to deployment. Continuous integration, this is nothing but the practice of automatically building and testing machine learning models whenever new code is committed to the version control system, that could be Git or Flash and anything for that sake. This ensures that a new code does not break the existing functionality of the model. Okay, let's see some of the steps that are involved in continuous integration. Firstly, I would like to pick up the code check-in. In this step, to check the code in the version control system, the code can be in the form of Jupyter Notebook or a Python script or a machine learning model script altogether. So the traceability of the versioning is very important here. Building. In this phase, the code is automatically built and dependencies are installed. If there are any errors or warnings, then the report would be generated to the developer. So and so error has occurred. Okay. In the testing, here the model is automatically tested to ensure that it meets the defined performance metrics. And finally comes deployment under the continuous integration. That is, once the code is successfully built and tested, the model is automatically deployed to a production environment. Okay, this was about the continuous integration. Now, let's move on the continuous training, what really happens over here. The continuous training process is more or less, it's all about, orchestrating and automating the execution of the training pipelines. This mainly depends on how frequently you retrain your model, depending on your use case, on the business value and cost of doing it. So some of the steps that are involved in continuous training are data preprocessing, where the training data set is cleaned, transformed, and processed to ensure that it is suitable for training. And then there is a feature engineering. So the features of the data set are either extracted or transformed into a format suitable for training. So new features are created out of the existing features. And then the model selection. A machine learning model is selected based on the type of the problem that is being solved. And then training. In the training, the selected model is trained on the data set, and the performance metrics are also recorded. Then we have hyperparameter tuning. The hyperparameters of the models are tuned to improve its performance. Then we have model evaluation. The model is evaluated against the validation, the data split to assess the performance of the model using various evaluation metrics on different partitions of the data. That could be holdout or cross-validation, anything. And moving on, model validation, the results of model evaluations are validated to make sure that the model meets the expected performance criteria. And then we have model registration. So here, whatever the finalized or the validated model is stored in a model registry along with its metadata. And then comes the third step, that is the continuous deployment. This is a process of deploying the machine learning model into a production environment. In this step, the model undergoes progressive delivery. That is, some of the deployment ways in this phase, canary deployments, or blue-green deployments and shadow deployments. So all of these are often used to perform smoke testing or A to B testing, which particularly or mainly focuses on model serving efficiency like latency or throughput, and so on. Okay, once we verify that the model works technically right, so we will have to test the model effectiveness in production by gradually servicing it alongside the existing model. So there is already a model that is running in the live, and we will create a separate environment to make sure that the newly trained model meets the business goals in a much more better way. Okay, on the live traffic. Okay, the steps that are involved in deployment are model packaging. Here, the model is packaged in a suitable format for deployment. And then we have model deployment. The model deployed in this production environment, either as a microservice or as a part of large application. Monitoring, the model is continuously monitored to ensure that it is performing as expected. And then we have finally updating the model. So in this phase, we update the models periodically, again, based on the problem that the user is solving, to incorporate either new data or to improve its performance as and when the data gets updated. So we have covered three major steps in the deployment phase. Okay. Thank you. Ashley, you shall proceed with the poll question.
Yes, thank you so much, Ashin. I appreciate it. We'll now go ahead and go to our first poll. If you're in Zoom, please go ahead and answer the poll just using the polling box that should pop up for you. If you're joining via LinkedIn Live, please use the chat box to submit your answers. I'll go ahead and read the question for anyone who can't see it clearly or just listening in. Do you already have the MLOps pipeline established in your organization? If not, are you planning to have an MLOps pipeline for your machine learning workloads? Yes, no, need more information to consider or decide, and no business requirements at present, may consider in the future. Please go ahead and just take a minute, if you'd be so kind as to answer that poll. I'll leave it up for a few seconds for you to review the answers. Again, if you are joining via LinkedIn Live, please just use the chat box to submit your answers. Thank everyone for answering that poll. It looks like it's leaning more towards need more information to consider or decide.
Okay. Thank you, Ashley, for the poll answer. Okay. All right. So in the very first section of this webinar, we discussed or we understood overview of the MLOps, what are the major components of it, and why it was required, why it is essential, and such things. Now we will go on to a very important section, that MLOps using SageMaker, how it could be achieved. So let's get on to the next slide. Okay, Amazon SageMaker. So here we can understand that, how Amazon SageMaker can help, organization harness machine learning. Uh, Amazon SageMaker is a comprehensive machine learning service enabling business analysts, data scientists, MLOps engineers to build, train, and deploy machine learning models for any use case, regardless of machine learning expertise.
Sachin, I hate to interrupt you. I apologize. Could you speak up a little bit? It's coming through a little faint for some of our listeners.
Okay, all right,
Thank you very much.
thank you. Okay, so let me repeat that. Uh, so Amazon SageMaker is more or less a comprehensive machine learning service uh, that enables business analysts, data scientists, and MLOps engineers to build, train, deploy machine learning models for their individual use cases, regardless of machine learning expertise. Let's say uh, in the in the business analyst, how it could help business analysts. So business analysts can make machine learning predictions using a visual interface using the SageMaker canvas. Okay, data scientists can easily prepare data and build, train, and deploy machine learning models on the use cases that they are solving using SageMaker Studio. Now, moving to MLOps engineers. So MLOps engineers can deploy and manage models at scale using SageMaker MLOps. Okay, so we went through what is SageMaker and what it can do. So here, let's try and understand the SageMaker inputs and outputs. So before we get on to the SageMaker pipeline and how it could help automate our machine learning cycle, let's try and understand how these models train and build using SageMaker. And for that, let me walk you through three different ways that customers are using SageMaker as of today. The first way is using built-in algorithms. So SageMaker provides 17 different algorithms for you to choose from. And you can see in the image, the training image and the inference image are highlighted or grayed out here. That's because SageMaker already gives them to you. What you need to provide is what are all the hyperparameters that you want to use and then provide the training, validation, and testing data that your model is going to use. So let's say this generates the model artifacts from the training, and that can be deployed into different environments. So that's the first approach, and more or less, very straightforward one. The second approach, and maybe more common, is it's more common because probably it is used when you want to have your own built-in framework or go with a built-in framework. Yeah. So instead of an algorithm that's going to figure out everything for you, you've got some interesting and used to framework that you can bring and use. Let's say TensorFlow or a PyTorch or MX9, and even scikit-learn as well. But you don't have to worry about all the details of building containers and optimizing these frameworks, because in this scenario, SageMaker built-in framework, it already has the pipeline. So you will have to just provide a training code and an inference code as a Python script. So that's the only additional piece that is involved or required here. But you get much more flexibility to customize your pipeline to fit all your needs. The third and the final approach is when you need even more customization. And this lets you bring your own container. So bringing your own algorithm or container, you get to build a custom Docker image with exactly the environments and the framework that you need. Particularly, if I have to mention, could be a Python packages, or additional data whenever that's required or in need. So in order to do that, what you have to add to your training and deployment steps here is producing or having these Docker images that are created by you. So here you just provide a Docker file, additional code and libraries, all the steps needed to be part of the build pipeline. So once all of these three are ready, SageMaker pipeline enables you to facilitate uh, all possible use cases. So one important thing to know that based on these inputs, the outputs and the artifacts that get produced under each approaches, such that these designs will help in understanding the level of automation that is required to solve your machine learning problem. Okay. Let's move on. Okay, we'll understand now the SageMaker built-in features. Okay, starting with the data preparation tasks, which include things like cleaning, transforming, and performing feature engineering on your data. SageMaker offers capabilities that can be plugged into any machine learning workflow. So you could choose to use a data wrangler to build your data transformation pipeline. And you can visualize using a graphical interface for that, or you can use SageMaker processing to build your data processing jobs. Either way, the tasks performed by these jobs can be easily plugged into your machine learning pipeline. And you can also use feature store to store curated features that can then be used as part of the pipeline for your training activities. So once this is ready, you can just see over there that the general input to this step is just the raw data, or you could even have some degree of clean data set. And then there's two different output that you can see here in this step that needs to be version, which include data processing code and your prepared data sets for training validation of your models. Knowing these key inputs and output is a key. The reason is this is essential for traceability and lineage in building your pipeline. Next, you have your model building activities where you are typically running through number of experiments. Okay, that is training, evaluating, and fine-tuning your model until its performance to the expectation of the organization. And here you'll be able to track each of those experiments that you have performed on a problem using SageMaker experiments, so that you can easily revert to the experiment that has resulted in the best performing model, and the inputs that have gone into this actually creating that model version. Okay. When you do find that the model is performing as expected, you can then register that the model in that particular model in the model registry, which stores key metadata about how that model was built, how it performed, and where it got deployed. You can also see here that we are picking up more outputs as we go to the next steps, right? So that is including our training code, our model artifacts, and again, each of this needs to be versioned for traceability. Next, once we find that the version of the model that's performing on the minimum threshold or on some kind of accuracy score that it is defined based on the KPI, right? So you can then use SageMaker deployments to take that model artifact, package it, and deploy it on one or more target environments. The next, similar to DevOps, where we build once and deploy many a times, with machine learning as well, something similar works. So while we train once and deploy many without retraining between target environments. So here in this deployment step, you are more or less packaging your model, and then you choose the type of deployment option that meets your criteria or the use case. Okay, that is upon hosting services using a persistent endpoint or using a batch transform or async inference. You will notice here that we also use SageMaker Model Monitor. That's basically to monitor the ongoing performance of your model over time so that we can be alerted whenever there's something like a concept drift or a data drift. All of these features of SageMaker can be used together, or you could just pick some features of the SageMaker that makes sense for your business requirements and your use case. So as you're building the machine learning pipeline. So we have all of these workflow steps and the task within each of these steps, but how do we actually build a pipeline that's able to automate these steps as well as incorporate all of these inputs, outputs, and artifacts as part of pipeline that should have some kind of end-to-end traceability. So this is where SageMaker pipeline comes in to tie all of these different steps together. Okay. Okay, the SageMaker pipeline, mainly this was introduced to facilitate the CI/CD service for automating, building, managing, and scaling machine learning workflows. Okay. From the perspective of building workflows, right, there's a Python SDK that is available for easily defining your steps, and the dependencies that is involved, the inputs and the outputs. For troubleshooting, SageMaker lets you visually see the pipeline that you have defined graphically and monitor the execution in real time and drill into them, or stop them, or rerun them, and so on and so forth, interactively while working on the SageMaker Studio. For managing model, SageMaker has introduced the model registry. That is, this works across the project, as we have seen, where you can register all your models and automatically can keep track of versions and metadata for your entire environment. And then there is, for automating and scaling purpose, SageMaker has got multiple built-in project templates that gives you point and click deployment of entire end-to-end CI/CD infrastructure for data scientists that's available. And this is also customizable. And lastly, with respect to the lineage, SageMaker pipelines keeps track of all of this throughout an entire complicated pipeline that is across steps and various dependencies. You can see where all of the data, you could see where all of this, the data that is coming from for your model and what parameters or setting that you have used. You can easily reproduce that and scale for thousands of other models. Okay, so this gives you to the collaboration between the data scientists across the team with ML engineers or the MLOps engineers, the DevOps engineers, accelerating the projects without taking a hit on the quality of the model that is being built in the entire process. Okay, let's move on to the SageMaker pipeline and its components. So let's take a look at how all of this works by focusing on the three main components that are really making up the SageMaker pipelines. First, we have the SageMaker pipeline, which is the SDK that I was talking about, that allows you to build automated model, build workflows that really focuses on orchestrating the task and the steps that are required for your machine learning building activities. Okay. This typically includes some of the common steps that are needed to prepare your data, train, evaluate, and then potentially, once you're done, to register the model based on the minimum threshold or some kind of project metric that is allowed. Based on this accuracy score or a specific threshold, whatever the object metric you are really trying to optimize your machine learning model on a number of iteration or on the number of experiments until you find a desired model version on the model performance, based on the model performance. So the key thing to note here is that these pipelines are often used during model development, But at the same time, the same pipeline code can be used during model deployment and can be used during the operational phase of your model retraining activities as well. And the second component of the machine learning pipeline is model registry. So model registry is a managed registry that usually or manages model metadata for model version that come out of the model build phase. Okay, um, based on how well it's performing. This is really helpful to manage multiple versions of the models for traceability and for a better transparency. Finally, the last component is the SageMaker project templates. So the SageMaker provides a pre-configured MLOps templates as well as the capability to bring your own templates. So each of these templates can be instantiated or called up multiple times to automate the process of setting up and configuring your machine learning pipelines. So later incorporating CI/CD practices such as automated triggers, source and version control, as so on. So you can see that these templates cover end-to-end workflow or only the model build phase or only the model deployment phase. And this is really to provide the flexibility for customer that may not use SageMaker end-to-end and rather want to choose one among them. So as an example, if you can, or if you are training outside of SageMaker, but if you're using SageMaker just for deployments, then you'll have to just choose deploy only MLOps project template. Okay. Yeah, so well before we move on to the next slide, that is the demo part. So here we are trying and explaining or understanding how we can adopt MLOps using SageMaker. So so far we have discussed various different components, right, that Amazon SageMaker is offering. Let's try and understand some of the key points that will emphasize us to use or adopt SageMaker for MLOps process. So we know or we have seen SageMaker that provides purpose-built tools and built-in integration with other AWS services so that you can adopt MLOps practices within your organization with a lot of customization. And using Amazon SageMaker, we saw we could build CI/CD pipelines to reduce model management overhead or automate machine learning workflows to accelerate data preparation or model building or model training or maintaining the quality of the models by automatically detecting the bias or the model data drift. And to altogether here automatically, we can also trace the lineage of the code, the data set and the model artifact that is part of the governance and the data security. So, yeah. Okay. Thank you, Ashley. We can proceed with the poll question.
Thank you so much, Sachin. We'll now go ahead and move on to our second poll. Again, if you're in Zoom, please answer using the polling box. And if you're joining via LinkedIn Live, please use the chat box to submit your answers. Again, the poll number 2 question is, what is the biggest challenge you face in scaling up your machine learning projects? A lack of resources, a lack of expertise, model deployment difficulties, inefficient workflows, or other? I'll give everyone a few moments to go ahead and review the poll and answer it for us. Again, if you are joining via LinkedIn Live, please go ahead and use the chat box to submit your answers. And I do appreciate everyone taking the time. It looks like it's split between a lack of expertise and model deployment difficulties. Thank you everyone so much for taking the time to fill out that poll. I'll go ahead and now turn the call over to Murali. Sir, please go ahead.
Hi everyone, my name is Murli Manohar. So I'm a data scientist and MLOps engineer for working at Idexcel at Virginia office location. So today's agenda for me is to cover a technical demo session on MLOps and how we can use Amazon SageMaker to implement MLOps. Uh, so before we dive deeper into the technical part, I'm assuming that today, like everyone joining for the webinar here, have like little to no experience on using SageMaker or MLOps. So with that setting in mind, I'm gonna like start from the introduction and explain like what are the various features of SageMaker and how we can leverage that to implement MLOps. Okay, let me share my screen. All right. Okay. So now, before we start, I know Sachin covered a lot of theory content going over each and every part and component of MLOps. But let me again start without the technical jargon, what MLOps is, and then take you to the SageMaker Studio experience. So MLOps is basically, well, we're trying to build and run each and every phase of a machine learning project lifecycle. And we are trying to essentially automate this entire life cycle by connecting each of these phases into one fully automated pipeline. And this is exactly where SageMaker helps us achieve this. So SageMaker is nothing but a service provided by AWS. It is a fully managed machine learning service that data scientists can use to build, train, and deploy machine learning models at scale. So let me just like switch back to the AWS management console and show you guys how we can actually open a SageMaker session. So if you go to the management console, go to the SageMaker and then click on Studio. And then you would have to initially create a user profile and a domain. So these are nothing but the required IAM policies that you would essentially need for the SageMaker to like interact with other services like S3 and all other services for building the infrastructure, and also the EFS, the storage platform, and so on and so forth. So when you click on Studio, it opens up. Just a second. Yeah, so this opens up and we can get to the home screen of the SageMaker Studio. Here, if you click on the left side, the home icon, you have several options, which are like important aspects of machine learning operations, as well as like an ML project lifecycle features that you can use to build, train your models, and even deploy those models to production and stuff. Here you can quickly open a launcher and create a notebook, or open a terminal and download code or whatever that you require. Okay, now that we have seen that, let's go to the slide. Okay, so let me start with the first feature of SageMaker that everyone's going to use to initiate a machine learning project lifecycle, and that is nothing but after you have the use case, business use case, you kind of explore the data and apply feature engineering or feature selection and do some exploratory data analysis. So SageMaker provides a really nice low-code visual interface for performing all these operations. So you have a very nice graphical interface, and like it kind of like serves everyone from every background, where if you have less coding background, even then you can still make use of this, and then like try experimenting with it from a click and drag approach sort of a thing. Or it can, even if you're an experienced coder, you can make use of it. I'll show you exactly now how we can use it so that we get the hands-on experience of using the data wrangler. So if you go to the SageMaker Studio, you can click on data, and then you can select the data wrangler. Once you select that, then we start by creating a simple flow. Now, I'm not going to start from scratch because creating a new instance will take time for it to warm up and run and everything. So I already have a uh, sample data flow created here. Now, this data, to give a brief introduction, is basically a churn prediction data set. And I'm just showing you a sample of how the data looks like. So these are the features that the data has. we don't need to get worried about what the use cases. Let's focus on how we can use SageMaker to kind of do certain operations like feature engineering or EDA. So once you have the flow created, you can connect the data wrangler to any number of sources. So for example, you can have the data stored in S3. You can have the data stored in EFS or any external, data storage provider like Databricks or Snowflake. Anyway, data lake. You can kind of like use a URI, unique URI, to connect the database to the data wrangler, pull in the data, and perform the necessary transformations that you would want to experiment with. And then finally, you can push it to the next stage, which is feature store. I mean, this is like an optional step again. One key component of the MLOps pipeline. We'll talk about it after we complete the data wrangler part. Okay, let's say that we have connected the data source. Here I'm using an S3 source. We can see that here. And then we can also see that this is more like a graph connection with nodes, right? And the flow is like it goes from left to right in one direction. So the key advantage here is that you can kind of like experiment. Even if you're an experienced coder, right, you can kind of like experiment different feature selection or feature engineering techniques. Like you can take one, if you decide you want to encode your features in a different way, you can take it in one direction, in one the top graph that we are seeing here, this line. And also like we can do alternative parallel experiments and have like multiple connections going forward, and based on which features are providing you better results for the model, you can select those features. Now let's see how we can actually open up and see how we can use these transformations here. If you want to check the data and the data type, you can do so by clicking on the double clicking on the node itself. And if you want to do apply some transformations or data cleaning or data wrangling, what you do is you click on the plus button here, and then you can select the necessary, like you can click add transform or insert transform after. So let me do a quick demonstration here. So I'm trying to add a transformation here. We can select the add step on the right hand side. If you select this, now this is what I was talking about. We have like a predefined set of transformations which are already there. So you don't really need to code anything. You can have the data, you can view the data features on the left side. And then if you want to like, let's say do, filter data by some column values, you can click on it, select on it. You can select the column that you want to filter for, let's say session, uh, items in session, and you can select a condition, like whatever the string is and whatever condition you want, and then a specific value, and just we can do add, and then that's actually done, and the data is kind of filtered. Probably we're going to see a shortened version of the data after this transformation is applied. Now if we go back, okay, now we see that like the transformation that we added is here, right? Now we can move this around, and then we can have it here. And then after this, we can do a add transform. And then this will kind of like, from this point, you can start experimenting and then do the feature engineering all the way up. So this is one way of doing it. But let's say if you have your custom code and, like, what you're trying to do, then again, you can have your own code in this. So here, what you do is, again, add step. Instead of the predefined function transformations, you select the custom transform. Here you can like you have like several options here. You can use Python pandas. You can use PySpark to work with IDEs for parallel processing. You can do that, or even like PySpark SQL is allowed. So let's say you're using Python pandas. You can just type in the code and then do whatever you want. Just like a sample. I mean, I don't want to go deep into it, but of course, you get the idea. So coming back, so let's say, okay, we have finalized the features and engineered, and then analyzed the data. So the next eventual step would be for you to, export to an S3 bucket location. And from that location, you can again retrieve back the data and then start your building and training process. But or you can kind of like push it to a feature store, right? Now I'll explain what feature store is. Sachin has gone over it, but let's just quickly see what it is again. So feature store is like one of the, I mean, it is basically a central location where we kind of save or store all our features, which can be reused in the future. Now, the key advantage, key benefit is that, we spend a lot of time, probably, like a month to 2 months to, work with some complicated unstructured data. And then we are trying to derive meaning out of it. And then after so much of time being spent, and then we have engineered the features, we are pushing it to the feature store. Now, the benefit is, now, if this data is something which some other team in your organization can actually use, they don't need to do all the feature engineering to explore or even transforming the unstructured data to a structured format. They can directly, like use the feature store to retrieve the features which was already engineered by your team. Now, that's where the main advantage comes from. So let's see how we can do it. I'll quickly show you, how you can actually create a feature store, to get a hands-on experience. Let's do it quickly. So you click on the plus icon, go to export, and then you have the option, add destination, and select SageMaker feature store. Right now, let's say we don't have a feature group created already. Let's create a feature group here. Select create feature group, and then okay, this will ask you, because our data doesn't have this particular column called event time. We need that. This is like a mandatory field, and then we'll be given the schema of the features that we have. Let's copy it so that we're going to reuse it in the future. Okay, copy, select create, and let's give a name. Let's give some name. You can give some description if you want. And there are two types of feature stores. One is online, one is offline. So when you have an online feature store, it is stored in a location which is quickly accessible. So there is low latency involved. For real-time inferences, you might want to use this. There is the offline store where you're storing it in S3. Let's pick some bucket here and the folder. Okay, here again, you would require a specific IAM role, which kind of like gives you the permission to read, write, and retrieve all that to work with the SageMaker. So we've selected that, good to go. And okay, here. So here we need to provide the feature name and the type. This is where the schema we copied helps. Just paste it here. It has the event time as well, which is a mandatory field. Click continue. So here again, so we need to specify these two things: a unique identifier and the event time, to keep track of when we are generating the feature. So that's going to help a lot to identify, if a specific set of features are actually boosting the performance of the model, then we use this to identify when the features were generated. So let's use user ID as the unique feature name. Let's select the event time here, fractional, continue. Okay, let's see. Okay, we can add tags if we wanted to. Create feature group. Let's see. Okay, it's successfully created. Great. Okay, now we can go back. We can select add destination, SageMaker feature store, and let's see. Churn prediction group 9 is the one we have created. You can see that in the time. Select that. Okay, now if we have see if the feature group we have created kind of matches with the schema that our data set has. Okay, it's saying event time column is missing, but it's giving you an option that we can add to our data set. Let's go ahead and do that. All right, so yeah, So I so feature group is created their matching. So we can click on add on the right hand corner. And as you see, like we'll pushed our features, which we have feature engineered using data wrangler to feature store. Okay, now let's see if we actually can see this features from the feature store. So we can on the left hand side, we can go to the feature store, select, click on it, and it shows all the feature groups that we have created so far. Group 9 is the one we have created now, which is active. Let's click on it. Okay, now this gives the schema. This gives the details. We have all the locations where it is stored and online, offline, all these things. Now, if we click on sample queries, right? Now, this gives you a sample query, a SQL statement where you can take the SQL statement and let's say you want to import this set of features which are present in the S3. So what you do is like you open up a new notebook instance in SageMaker and or even Jupyter Notebook, and then you can connect it using the S3 URI. You can use the Athena, Amazon Athena to query the features using this. And then what you can do is you can basically then convert the data frame to a pandas data frame. Whatever data you've queried, you can convert. It will be in table format, right? Because you are like using a SQL query to pull the data. You can convert it into a pandas data frame and proceed with the building and training stages. So, okay, so that completes feature store. Hope we've covered that. Now, okay, now that we have the data in feature store, now let's see what we can do with the engineered features, right? Going back to the slides. All right, so, okay, so this SageMaker processing job, so it is a feature of SageMaker that enables you to pre-process data and post-process output in a scalable and cost-effective manner. This is like an integral component of SageMaker because all these jobs, right, training jobs, hyperparameter tuning jobs, all of these follow a similar pattern. It has all the key benefits of providing an easy way to run custom codes on your data. You don't have to worry about managing or setting up the infrastructure. So basically what you can do is, you can have a low cost notebook like a T3 medium EC2 instance, which is the cheapest. And then you can have all your code. And depending on how much compute resource that is actually needed for this particular job, probably for data feature engineering, you might not really need a GPU instance, right? Let's say, but what you want to do, the model, let's say you want to apply some BERT model, which requires a GPU for the training to get completed faster. Then now we are looking at like a CPU instance and a GPU instance. Right now, if you take a GPU instance and run all these steps in the same GPU instance, you're gonna run a lot of costs associated, right? Because a GPU instance is not really required for some low power performing tasks. So this is where this SageMaker's processing jobs gives you that benefit. So these are like like self-managed EC2 instances that are that are spun up whenever you start the processing job, and then it will carry out all the steps or transformations that are in the code. And then once that is completed, it saves the output in a specific location in S3, and then the EC2 instance is like automatically terminated. So now what this means is that you're saving a lot of money because you're just running it for the job's duration. Okay, having said that, let's go to the studio again and see how we can actually build a feature, build a processing job and run it. So I'm going to use a different notebook for this. And okay. Okay, so we kind of initiate the session with the session and give the execution role, bucket, and everything. Those are the default settings that you kind of like use whenever you start a notebook instance and connect the SageMaker service. So here, what I'm doing here is basically with this Jupyter Magic command, I can create a script called preprocessing.py, which will have this bit of code, right? Now this bit of code, I'll just like specify what this is a simple data feature engineering stuff that is happening here, right? Like whatever feature engineering we saw in this data wrangler, we don't really need data wrangler if you're trying to use the processing job. If you're experienced in coding and if you have like, this is a simple use case, we can probably get away with data wrangler. But if you have like a lot of steps, a lot of complicated transformations, image processing stuff, if you have data as image, processing job is really beneficial. You can have all this code here and create a script and save it. So once you run it, this will be saved. And then what you do is you build the processing job using this class that the SageMaker Python SDK provides called sklearn processor. So you import this class and there are a bunch of parameters which are very important. I'll just go over them because it's very important and gets repeated itself in the subsequent part of the demo. So when you import the class, you specify the framework version for this which you're using. You specify the execution role. This is very important because SageMaker, right, is a service which has multiple features, which has their own services. So when for example, data wrangler and feature store are like two different services. For SageMaker to interact with each one of them, and also services like S3, it requires like a specific IAM policy with permissions enabled. That's why you're always using this role as a parameter here. You have to pass it, and then you can specify an instance type. So we are selecting an MLM5 large instance for this, which is still an overkill for what we are trying to do here. But yeah, just so like we are using a CPU based instance. And there is a argument called instance count. Now that is set to 1. Now, if you want to like do distributed training or parallel processing, you can kind of increase this number to 2 or 3. Now, what this does is, this is going to, when the processing job is run, this is going to spin up 3 or 4, EC2 instances parallel, and then it's going to split up the data or the features that is retrieved them from the feature store, and then like pass it to all these instances parallelly, so that parallel processing is happening. You're saving time. This is hugely beneficial if you are dealing with big data, not like a smaller data set that we saw for this use case. Anyway, so you can name the job anything, and then whatever you have defined here, you can like pass it in this sklearn processor that run function. So the most important thing is, right now you're seeing the entry point of this run command. That is the pre-processing.py. This is nothing but the script that we have created here. So we are passing that script, and then the input and output locations. Now this will automatically pick up these locations and use the pre-processing script, and then the job will run. Now let's see if I can initiate the processing job again to show you. Okay, now I ran the cell again. Now you can see that the processing job is getting started. Okay. Now I'll show you how you can track it. Basically, you go to the SageMaker on the console. On the left-hand side, you go to processing. You click on the processing job. This opens up a new page which shows all the processing jobs that have been completed and then processed. So you can see this. I just created a few seconds ago, initiated it. We can see that. So if you click on that, now it gives you all the information about the particular processing job, when it is created, processing time, the role, all these things that we kind of define, right? We define all these instance type and everything. So you can see all that. And if you click on logs, it opens up a new screen where you can look at the logs. Now I've already opened up because it does take a couple of minutes or so depending upon the time. So this is how the CloudWatch logs look like for a processing job. As you can see, it's a processing job logs here. Now what happens? So what you're seeing is basically the output, right? Like when a new EC2 instance is spun up, you're gonna see that all these libraries or whatever is required for running that script, it will install it. So that's what we are seeing. So it is setting up the environment and like feature group and all that, and then finally whatever code that we would have given in the pre-processing script will run, right? Now this thing will run over there, and suppose if there are errors, trust me, like if you're actually working on a real world life case use case, you're gonna run the processing job multiple times and debug, look at the output, come back, make changes to the code. So that's gonna happen. So The logs are like a very important thing here. So that's how you look at the logs. So that's there. Okay. So once this is done, like the final features will again be saved. Now the processing job here doesn't involve feature store, but you can like push it to feature store and again retrieve it for the next part of the pipeline. Let me go back to the slide. Yeah. So processing job, similar to processing job, training jobs is exactly similar to that, but it is used for training the model, machine learning model part or phase. All the advantages that we discussed for the processing jobs applies here as well. So let's save time and quickly go there and see how that is done. So for the training jobs, you're going to define a different sort of parameters specific to the training. Now, Sachin did mention clearly that Amazon SageMaker in their ECR provides a lot of popular pre-built algorithms like XGBoost or linear learner or anything from TensorFlow, PyTorch, or Hugging Face frameworks. If you want to apply BERT or any of those popular models, you can kind of like go to their web page and find out how you can call them. So basically, you're going to give the here XGBoost is the framework we are downloading. So we can specify the version and get the address of the Docker image that is stored, right? Now this is like a pre-built URL. Now Sachin also mentioned that if you guys paid attention to that, there are a couple of alternative approaches like bringing your own model or bringing your own container. Now suppose you are doing transfer learning and then downloading a pre-trained model and then fine-tuning it, have your own embedding layers or whatnot. Now you can kind of like package those things all into a custom container, and then you can create an image, and then suppose your organization has like a private artifact, you can just push it there, and then you can bring it again to the notebook here. So in that case, you might need like a couple of more steps. It might need a couple of Lambda functions for authentication and stuff, but ideally the format remains the same thing. So you kind of retrieve the training image and then define the input and input training data and validation data, and then pass this as the parameters here. Similarly, if you want to use a GPU instance, you can specify, some GPU-based instances like G4DN or P2 series, P3 series. There are also popular GPU options to use. We can specify the instance count here. Also, we can do parallel processing or distributed training. And then a SageMaker session, and then you pass in the hyperparameters. So we are dealing with a simple use case here, right? We are hard coding all these hyperparameters here. C, max depth, learning rate, gamma, all these things are hard coded. It's going to be a simple XGBoost fit using the training and the validation. So once you run it, you can go to the console. On the left-hand side, you can go to the training job section, and you can probably check it should have started, but yeah, if you go there, it's the same thing. You can view the logs, you see all the statistics that you require, and then the CloudWatch logs will kind of like look similar, right? So the training and everything will happen here. You can debug and see what's happening. Okay, let's quickly go back to the notebook. So that is training jobs. So once the training is completed, the model will get saved, right? Now the next part is like hosting the endpoint and the model, but then I'm going to stop here and go to the SageMaker pipeline stuff, because till now, till this point, we have been looking at individual components, and these are like important components, and we saw how to build them. Now let's see how we can automate them, right? Okay. I'm opening a new notebook again for this. So let me give the basics again. So we are initial sessions and IAM roles, policies roles, where we are defining all that. Here, what we are doing is we're kind of like giving we are hard coding certain variables which will be reusing in the pipeline, like for the threshold for selecting the model, performance, and everything here. And the instance type and everything is defined here going forward. Okay, now this is where the fun part is, because we have already seen the processing job and the training job, right? Now, if you see, right, we are doing the same thing. For this use case, we are writing a processing job script. Now, how we are using it, there's a difference here, right? Now, we just directly ran it the last time. Here, we are saving it in a variable, and then we are just like passing that as an argument for the processing step from the SageMaker pipeline using the SDK again. So in a similar manner, we can kind of like define a new step here, which we didn't see, called hyperparameter tuning step. Here, instead of hard coding it, what we are trying to do is like we are trying to find the best set of hyperparameters by giving a range. So the learning rate is given a range from 0 to 1. So what happens is when this hyperparameter tuning job is triggered, we can also see that it will like have multiple instances train the model with various various values for the hyperparameter and finds the best set of hyperparameters for the model performance. So so that's what happens. So this is one step. Now let's go to the next step. So we are defining here model evaluation step. So I don't want to take too much time here. We are again defining a script for this, how we are performing the evaluation with a performance metric score. We are taking an AUC ROC score here. And then we'll be using that script within this function for the model evaluation step. And then we have the model registry step. If you remember, Sachin mentioned about model registry, which is kind of important part of MLOps pipeline, because you can do model versioning and lineage tracking with the metadata that is used for each model, because we need to find the best model, and also for capturing drifts and everything. This is very important. If the new model after retaining doesn't work as expected, trust me, we need to like fall back to the previous model. A lot of times we've seen organizations do that when whatever services, insurance services they're offering for has failed. Even we have seen that with Extract as well. But anyways, coming back. So this is like an important step. We are defining everything here. We are defining the instance type and everything. And the condition based on which the metric performance metric is in which we approve or reject a model. And then we kind of like include all these steps in one particular area and use call the pipeline class from the SageMaker Python SDK, and then tie in everything that we saw. All of these steps and parameters, we pass it through this pipeline class, and with the steps we define it, and then we kind of start the pipeline. Let's see if I can start it again. Okay, pipeline is getting started. We can, so this is the fun part. Now you can, once this is run, right, go to the pipeline section on the left hand side, and it will show all the pipelines that are present. There are several pipelines we have tested as a part of POCs, and select the latest one, and you see like every subsequent pipeline that is getting executed succeeded is already there, and this is the one we just triggered right now, 30 seconds back. If we double click on it, we can see a nice visual representation of each of the steps. Right now, we can click on it and see the details. Now, because this is still running, let's just like quickly go back. Okay. So let's pick one which is already succeeded. Now we see a nice graph. Once we see that the green color mark is showing that it's completed. We press at each of these nodes, we can see the input, all the parameters that we have set are here. You can see the location where it's getting saved. And the CloudWatch logs that we talked about, we can go directly to the page from here. For each of these nodes, we can go to the logs, check the logs directly from here, and that opens up the page, and click on view logs. You'll be able to do that. So I don't want to show it again, but yeah, so essentially that is what we're looking at, right? Depending upon the nature of the step, we see all these steps, and it kind of like ends where check AUC score for performance metric, and then we are registering the model in the model registry part. Now the model registry, to check whether we are actually the model is getting registered, again on the left hand side, we go to the model registry, and now you click on the model package group which you have defined it within the code, And we see that there's a bunch of models. Like we see that I've approved one model, I've rejected one model. Let's just like open the latest one. Now we see that, okay, it's pending, right? You can update the status. If you want to approve it, you can approve it, and then you can say, hey, performance metric good or something, and you update the status. This means the model is registered and versioned, and uh, it's kind of saved. So once this is done, we can also see, what score it had. It had an ASC score of 0.98. That is the reason it actually crossed the pipeline and came to this part. And then it had like a human in the loop for me to check and actually approve it manually. So that's very nice. So we have all these things. I'm not going to go over them, each one of them, due to the time constraint, but let's quickly go back to the code. Okay, now this is the pipeline, right? Now I'm just showing you this, right? Now this is not like a extensive ML project lifecycle or business use case. Like we have just finger picked a certain steps and then just club them together and then to show for the demo. Now an extensive ML pipeline will have all the steps, even like model monitoring, retraining, all these steps which we are not going over today since we wanted to keep it like an introductory topic. But I want to say, okay, we can even have the model hosting step as a part of this, like add that step, define it in the previous cell blocks. We can do that. But so model hosting, I'm going to show you. That is the final part of today's demo. So what happens now? We have independently trained the model. The model is saved in the S3. Now we can actually host the model. Now, this is the most fun part of SageMaker. You can just deploy it with just a few lines of code. Now, this is a very basic deployment. We don't have any endpoint configurations for tracking the model or model monitoring or baselining the data, or several other options are there. It's a vanilla deployment. It's not like some of the other deployment techniques that Sachin talked about in the presentation, like canary deployments or blue-green deployments. We're not doing any of that. So this is like a normal deployment. Let's see if we can try running it again. So now go back to the management console, go to inference, click on endpoints. Now you see, this is like a new endpoint that is getting created. So these are, that is the endpoint, right? Now we are creating this endpoint with a specific EC2 instance. This is an MLM4 large. So depending on what sort of inference request that we are trying to serve, we can pick a specific instance type. Now we need to keep in mind that once this endpoint is created, it's going to be live. So it's going to be costing you 24/7 as long as the endpoint is live. So I really want to bring one of the best practices of using SageMaker is that you need to kill off the endpoints. If you're just creating it, if it's sitting idly, it's just going to cost your organization. So how you can do it, you can select it, select delete. So that will get deleted. You can refresh it, probably take, yeah, it's already deleted. So ensure that if anyone new is like in your organization is trying to do some POCs, and then creating these endpoints are very simple. You just like run the same cell block a bunch of times. SageMaker does the creation under the hood for you. So we end up like creating 4-5 endpoints, and then that just sits there, and then if the person doesn't know how to do it, it's gonna get charged. So yeah, that's one of the best practices. But yeah, once you have the endpoint ready, you can configure it. The serialization, deserialization for passing the payload. You can do that with this function. SageMaker SDK has all these things, very simple, few lines of code, and then you can take the test data, you can pre-process it, and then bring it to a format of a payload, and then define a simple function here. This is a simple function here, but if you want to like serve inference requests for a complicated model like a BERT architecture or even a GPT, you'll probably have an inference script also prepared, and then you kind of like pass like endpoint configurations where you're passing those scripts. So that's going to be a little more complicated, of course, but a simple thing, you can directly do a predict function within the SageMaker notebook instance and pass the payload. We see that I've already run the cells before, but we're getting the confusion matrix. after the predictions are received. So we can see the true positives and the false positives and all these things. Right? So having said that, so this is like the deployment part, right? This is a basic vanilla deployment. So this deployment part could also be combined with the pipelines. And once you have this in the pipeline, it's like a fully automated pipeline. Whatever steps you're going to add, when you trigger the pipeline, that will be one particular job, and you can track that from this graph that we saw. Uh, so yeah, and now for a bigger pipeline with multiple more components, there'll be more nodes here. After this, probably will be the deployment node, and then after that, we'll be seeing like model monitoring, retraining, feedback loop. A lot of things could be added, customized, depending upon specific use cases. Uh, so I think I've covered a basic, like end-to-end ML, pipeline. Yeah, we're almost there. So I guess yeah, I guess we're done with the technical demo. Let me go back to the slide. All right. All right. So yeah, so in summary, we've looked at how we can automate the entire ML pipeline using SageMaker. We've seen the various features and what benefits they bring to the table. One of the most important benefit, with MLOps is that if a large enterprise or organization, if they adopt the best practices of machine learning operations, using a cloud service provider like AWS, using SageMaker, they build the infrastructure for building, training, and deploying the models to production. That can actually scale up and be elastic, and that can be reused. Now, this will save tons of time for the organization for moving the models and deploying them in production. Like typically we have seen organizations take like 6 to 8 months to just move the models to production from the prototyping stage, and half of the models don't even make it to the production stage. Some problem happens and then that's put on hold. Now, when you have like a very nice robust MLOps pipeline, you can reuse it or even like customize it based on newer use cases. This way, the organizations could save tons of time, and then the data scientists and ML researchers, ML engineers can actually focus on solving the business problem and probably increase their productivity and efficiency. So this is like a um, very key. I mean, one of the main benefits of employing machine learning operations to your work agenda. So that is what I wanted to say, and I think we are done with the presentation and the demo. So we can
Thank
move to
you.
the poll. Thanks,
Yeah,
Ashley.
thank you, Murali. I appreciate it. So we'll go ahead and finish with our final poll. Again, if you're in Zoom, please answer using the polling box. But if you are joining via LinkedIn Live, please use the chat box to submit your answers. What level of machine learning performance metrics are measured in your company? No measurement of ML metrics, like time to production. High level measurement is available. You're looking for low level. Or low level or detailed analysis of ML performance is available. Please just take a minute to go ahead and fill out the poll if you'd be so kind. And thank you everyone for reviewing the poll. It's looking more towards it's leaning towards no measurement of metrics at this time. I will go ahead and end the call. This concludes today's session. Thank you very much for joining. We appreciate it. I hope you guys have a wonderful weekend and a wonderful rest of your day. Thank you so much.
Thank you, Ashley. Thank you.
Thanks, everyone.